We're on page 24 now, looking at another example of our backpacks. And let's look for, in our problem, let's look for the key information. So we're told it's normally distributed, and it's got a mean of 3.3, it's got a standard deviation of 0.3, and we want to find the probability that a backpack weighs more than 3.7 kg. So there's our key info. So we're going to start with our distribution of our backpacks, our X distribution, and that has a mean at 3.3 with a standard deviation of 0.3. And we're interested in the probability that a backpack weighs more than 3.7 kg. So on our axis, 3.7 is above that mean of 3.3, so I'm just going to put a line about here, and that's going to be about 3.7 kilos. And we want to know a backpack weighing more than that. So I want this area above it. Okay, so above that point, I want the more than area. So we need to convert this into a standard normal distribution. And let me draw the curve. And so this is going to have a mean of 0 and a standard deviation of 1. And we need to find what this z value here is, so that this area that is the same as the area that we've shaded in of 3.7 above. So to do our conversion, we are going to use our z formula for that. So let's have a look. Z equals x, take away the mean over our standard deviation. And in this case, our x value is our 3.7. Take away the mean of 3.3, divide that by our standard deviation of 0.3, and that is going to give us a z score of 1.333 to 3dp. So that tells me that my z value over here is actually 1.333, and we want to know the probability of being above that value. So let me just, oh, I don't want that, go back. What we're doing now is, if I get my pen right, there's, oh gosh, that was a terrible normal distribution. Here's our normal distribution, or rather our standard normal distribution. There's our mean of 0 and a standard deviation of 1. This value here of 1.333 and the area above it, that's the one we want to find. Now what we've got to remember is if we go back and look at the table, okay, so if you go back to look at the table of values, the picture on the table of values colours in this area here that I'm just colouring in now. So it colours in the area between a mean of 0 and the value of 1.333. So that means we've got to be a little bit clever now. We've got to be thinking about how we're going to do this. So let's think about, well, what we do know. I know that the probability for a z distribution being above a mean of 0, that probability equals 0.5. Okay, so 50% of the data is above the mean, 50% is below the mean. So if I was able to look up on the table and find that area there, the one that we've shaded in, oh, change, come on, pen colour, behave. Where's my pen colour? Okay, there we go. So if I was to look and find how big this area here is from my table, we would find that that area is 0.4087. So then we've got to take our prior knowledge and that piece of information together to find out, well, what is the probability that we are interested in. So let me go back and change my pen colour again. So that, what I really want to know, oops, not that, I really want to know what's the probability that z is bigger than 1.333. That's going to be equal to my value of 0.5, take away this value of 0.4087. okay? And the reason for that, I'll try and draw this in a different colour to show you what I'm doing, is I know that this whole area, that whole area that I'm shading in, is 0.5. And if I take away the piece that I know, that we've been able to find from the table, so if we take away that little piece of 0.4087, so if I subtract this part here from it, okay, then that should tell me what we've got left over, which is the area that we're interested in. Okay, so then we can see we've got that tiny little wee tail piece left over, and that's what we're trying to find. And so that will give us, when I subtract those two numbers, will give us a value of 0.0913. So that is equivalent. So this probability for our z distribution is an equivalent probability on our x distribution. So now if I was to go back and say, what's the probability that our x distribution is bigger than our 3.7 kg that we were interested in, that's the same probability that z is bigger than 1.333, which we've just gone and found is 0.0913. So then we need to write that up into a sentence form because that's how it was given to us in the question. And so we're going to say the probability that backpack weighs, oh goodness, my handwriting's terrible, sorry girls, more than 3.7 kg is 0.0913. Or if you want to express it as a percentage, you could write it as 9.13%. And there we go.